and right off the bat, I have no idea what to do, which is kind of scary because we have tests.
Let's have a look at what they have here.
You can go all the way down to where it starts, like, it should be CL7112.
Okay. So to find out whether you understand something, all of their reading and whatever 2 pages they had above this means nothing. The only thing that matters is, can you do the problems? Find an exponential function that satisfies each of the following sets of conditions. Has a y-intercept of 0, 2. Okay? So our general form is y equals a to the bx. Excuse me. A b to the x. Well, they're saying this point is on that equation, 0, 2. So that lets me solve immediately for what?
X?
No, the point that has to be on the curve is when x is 0, y is 2. So let's plug in 0 for x and y for 2 and see what happens. And normally just having one point wouldn't do a lot of good. But in this case, it does a tremendous amount of good, because this solves for a, because b to the 0th power is always 1 no matter what b is, which means a is 2. So now we have y equals 2 b to the x, and we want to solve for b. And they say a multiplier of 0.8, I assume, what does that mean?
I don't know.
Shouldn't have poo-pah'd all this writing, because I'm not familiar with that term. Let's see if they tell us what a multiplier means. Multiplier. I can only presume they mean this, that b is equal to 0.8. I might be wrong with that. It really kind of depends on their definition of what they mean by a multiplier of 0.8. I can't even think of what that can mean other than b, even though I don't really like it as a word for b. But let's look at the second one. So again, we have y equals ab to the x, and it goes through 2 points. Well, as long as one of those points is x equals 0, that's going to allow us to solve for a. Once we solve for a, this point will allow us to solve for b. And then we will have a specific equation. So how do we solve for, what do we do?
3.5 equals AB to the 0.
Okay. Now what?
A equals 3.5.
Okay. And now our second, in other words, we have this much of the equation now, but we still don't know what B is. But this second point will allow us to solve for B.
How?
Well, by plugging in the x and the y coordinate. In other words, 31.5 is the y value, and that's equal to 3.5 times b squared. Because they're telling us that when x is 2, y is 31.5.
But, oh, okay.
Now you have one equation, one variable, you can solve for b. How do we do that? What's the next step in solving for b here?
Dividing?
Okay, you have your calculator. What's 31.5 divided by 3.5? Bet 9.
Yeah, it is.
Okay, now how do I find b?
The square root of 9?
Uh-huh. So what's b equal to?
3?
Yeah, now normally I would say plus or minus 3, but when you're dealing with exponential functions like this, b is always positive. So we're only going to use the plus 3. So now what's the equation that they are looking for? Y equals what?
3.5 times 3 to the second.
3 to the x. We always, when we get back to our final answer, we always have an x and a y in there. Okay? In other words, we start with y equals ab to the x. There's 4 variables. We don't know any of them. What we want to end up with is knowing what a and b are. We're always, once we get our final answer, in this case, we've solved for a, that was 3.5. We solved for b, that was 3. Well, now, this will answer any question as to what will y be when x is 10, or what will y be when x is 100. So this is called the specific equation. This is called the general equation. The difference between the two is that with the specific you have solved for a and b.
Okay. Mom, can you come get these dogs, please?
Now, it looks like you're into arithmetic sequences also, correct? And geometric sequences? Question 7.
Yeah, 71114. I didn't know how to do D.
You know how to do 71113? Or do you not need to know how to do that?
I don't know how to do that one. I don't think it's possible, though.
This one right here?
Yeah.
Oh, okay. I see. Help Sam create his sequence. Well, we'll give it a look. This is a completely different topic than exponential functions.
So do you want to do that one first, then?
Well, it depends on whether you're going to need to know about arithmetic and geometric sequences. They're pretty important. You're going to have to know, if not now, later. Let's have a look at it. Wants to create an arithmetic sequence. First of all, what is an arithmetic sequence? Let me write a sequence. A sequence is just a sequence of numbers. Okay? What makes this? This is an arithmetic sequence. Why?
Because it's adding by 3.
Yeah, because there's a common difference between every number. So if I change that 13 to a 12, that's no longer an arithmetic sequence. Still a sequence, but it's not an arithmetic one. Okay? So at your level of math, we're going to deal with two types of sequences, arithmetic and geometric. This would be a geometric sequence. Why?
Because it's multiplying by 4 each time.
Multiplying every term by 2.
Oh.
So there's a common ratio. In other words, if you want to find the common ratio, just take any number and divide it by the previous number. 8 divided by 4 is 2. 32 divided by 16 is 2. So there's a common ratio. That's what makes a geometric sequence. Okay, so he wants a sequence where the first term is 8 and the 7th term is 512. Now you realize, I mean, you understand that's what T of 1 means?
I didn't know that.
Yeah, that means the first term in the sequence, and I've written an 8 because he says he wants to build it with 8 and 512. Well, pretty sure that that is a geometric sequence. Let's see. It is. Every term is double the previous. So I can definitely build a geometric sequence with those two terms, where the first term is 8 and the 7th term is 512. You see how I've done that?
Yeah, I don't understand like how you got that so quickly.
Just by knowing that 512 was a exponent of 2. In other words, I know that 2 squared is 4, 2 cubed is 8, and if you just keep doubling it, you get to 512. So I knew that 512 was in the doubling sequence. I wasn't positive that it was the 7th term starting from 8, but it was easy enough to double each number. So it definitely can be geometric. Now let's see if it can be arithmetic. Well, almost certainly it can be arithmetic, right?
Yeah.
Because it's all we have to do is find the difference. Well, now hold on. Maybe it can't be arithmetic. So we've got to cover 504 spots.
Wait, why did you minus 8?
Because whatever common difference I come up with, 6 of them added onto 8 have to equal 512. So I subtracted 8 from 512 to get 504. Then if I divide 504 by 6, I get 84. Which means 84 is my common difference. So this term would be 92, 88 plus 84. In other words, let's check it. And I'm going to add 84 to 92, which is 176. I'm going to add 84 to 176, which is 260. And then 344. And then 428. Bingo, 512 is next. Now, knowing to do precisely that, you have to fool around with sequences for a while before you figure out that you got to divide it by 6 and not 7. Because I really have only, in other words, whatever my common difference is here. Let's go through why I did that. D is what usually represents the common difference. Well, how many do I have to have between 8 and 512? Well, I got to have one. Hold on, I got to have 1, 2, 3, 4, 5, 6. So there are 6 common differences between 512 and 8. So that's why I took 512 minus 8 to get 504, and I divided it by 6 to get a common difference of 84. And that works. So it is possible on this problem to create both of these sequences. We just did it. Now, maybe there's a nicer way to do it. There are a couple of formulas that apply to arithmetic and geometric sequences. Have you gone over them? Do you want to go over them? They're called nth term. This one. Make sure you understand.
Yeah, that was always confusing.
Okay. Well, let's make sure you understand. Let's take away that confusion. Let's look at the sequence we just wrote. Because this is only the nth term for an arithmetic sequence. If I said, what is the third term of this sequence, and I didn't know what it was, I could use this formula to figure out what it is. What is the third term? Well, it's the first term. What's the first term?
I don't know.
8.
Oh, 8, okay.
Here's our sequence. 8, 92, 176, 260, those 7 numbers. Okay, so if I want to know the third term, I'm going to look at the first term plus the common difference I figured out was 84. Well, n is 3 because I'm looking at the third term, so 3 minus 1 is 2. And I'm going to take 8 and I'm going to add 168 to it to get 176. Bingo, that is the third term. So that's how this explicit nth term definition works.
Okay.
Tell me what the fifth term is. Common difference was 84. In other words, they have to give you enough information that allows you to calculate these. But it's definitely worth us doing this. You're going to have to know how to do this. So the fifth term is the first term. What's the first term?
8.
Plus the common difference. What's that?
84.
What is n minus 1?
I don't know.
What is n? 5. Yeah. In other words, that's what this means, is when I say what is the fifth term, I'm saying what is everything when n is 5. So I'm going to make this 5 minus 1. So the fifth term would be 8 plus 4 times 84. And that will give us that fifth term that I erased. So that's how arithmetic sequences work. As long as we're talking sequences, let's go over the geometric sequence that we just wrote also. This sequence right here,
yeah.
In other words, this means the first term is 8, second term is 16, third term is 32, up to a seventh term of 512. Well, for a geometric sequence, the formula for the nth term is the first term multiplied by the common ratio raised to the n minus 1 power. So let's go through. How would we get the third term? If we didn't have it written there, and I just told you it was a geometric sequence where 8 was the first term, and it has a, what's the common ratio? What's R? You get R by taking any term and dividing it by a previous term. If it's a geometric sequence, all of those are going to be the same number.
Okay.
So what is R here?
2.
Uh-huh. So what is A sub 3 equal to? What's the first term?
8.
This is why this is in the exponential section, because we have to use exponentials to solve these. What is the exponent to this going to be?
8.
What's n minus 1?
7.
What's n in our example?
I don't know.
Well, look, right there.
Oh, 3.
3. I said, what is the third term? So n is equal to that number. Whatever term you're looking for, that's the nth term. It's just got funny terminology. You're just going to have to get used to the terminology. But when somebody says the nth term, they mean, well, if n is 6, they're looking for the 6th term. If n is 11, they're looking for the 11th term. So what is the exponent on this 2 going to be?
3 minus 1.
So this should be 8 times 4. The third term in our sequence should be 32, and it is. And that's really pretty straightforward. Getting those two formulas down is really important. You need, in fact, let me rewrite them, because that's the geometric one. And then the arithmetic one is a sub n equals the first term. Notice that everything is based off of the first term. A sub 1 plus the common difference multiplied by n minus 1. Notice the n minus 1 in both expressions.
Yeah.
The key in this one is D, just the common difference between each term in the sequence, and the key in this one is R, which is the common ratio between each term.
Okay.
All right. Got just a few minutes left here. Which one did you want to look at? D?
Yeah.
Okay. What do I do with a minus 1? No matter what kind of an expression I have, if I have a over b and I take it to the minus 1 power, what happens to it?
B to the first over a.
Yeah, it becomes b over a. In other words, you just reciprocate it. That's it. If I had a over b to the minus 2, then it would be b over a to the positive 2. So D has 3 over 5x, all of it in parentheses, to the minus 1. What's that going to equal?
5x over 3.
Simple as that.
That's stupid.
Well, that's actually the simplest one of the 4. Let's do the first one.
What?
Well, what's this?
1 over 3 squared.
Okay. Which is?
9.
1 over 9.
Oh.
So 1/9. In other words, for A, I had to do 2 steps. I had to do that, and then I had to square the 3 to get that. For D, I just had to flip it. I had to do one thing is all. What's m to the minus 4 equal to?
1 over m to the 4th.
Now what is 1/2 to the minus 3 equal to?
2 to the 3rd, which also equals 8.
Good. All right. Let's, well, we can do these last. We can do a couple more here if you want. What is 8 to the 1/3?
8 to the what?
The next problem, 8 to the 1/3?
3 square roots of 8 first.
What's the cube root of 8? What number multiplied by itself 3 times will give you 8? I know you know it because we just did it with C.
2.
Okay. So the cube root of 8 is 2. Now it gets a little more complicated. What is 16 to the 3/4? Which one do we do first, the numerator or the denominator?
Denominator.
What's the 4th root of 16?
2.
What's 2 cubed?
8.
That's exactly how you do those. Do the denominator first, then do the numerator. In other words, we took the 4th root of 16, we had 2. So this is really the same as 2 cubed.
Okay.
And the very last one, 125 to the 4/3. Do the bottom first. What's the cube root of 125?
15?
5.
5.
These are always going to be small whole numbers. They're not going to give you problems that the answer would be 15. The answer is either going to be 2, 3, 4, or 5. Okay, so this is now 5 to the 4th. Again, 8. How about that?
Wow.
April Fools. Gracie, I'll talk to you, or sorry, Grace, I will talk to you next time.
Okay.
Okay?
Yeah.
All right, bye-bye.
Thank you.
You're welcome.
Okay.
What? Sorry? Go ahead.
My mom wanted to ask you something really quick.
Okay.
Can you email me or my mom an invoice? Because she doesn't know what she owes you.
I did this morning.
Oh, he said he did this morning, Mom.
To make sure that I sent it to the right place. Hold on.
Okay. I don't know if you sent it to mine or to hers.
I think I sent it to hers, but here I can let you know in just a second. I sent it to, are you the alien? No, you're Radliff GL? Is that your email address?
Yeah, that's mine.
That's where I sent it.
Okay.
I don't have your mother's. If maybe, I don't know. Can you forward
I'll send you, yeah, I was going to say, I'll send you her email address through my email.
Okay. Forward the email that I sent you today to
Okay.
her and me. And then I'll have her email address as well as yours. Now,
Okay.
what I sent you today doesn't include tonight. So it's going to be $16 more than what I sent you today.
Okay.
Okay?
Thank you.
All right, Grace. Talk to you next time.
All right.
Bye-bye.
Bye.